Hi, this is Paul again. I've got another new video to show you, and I'm calling this Keep CubicWonder Dirac 3D Geometry for the Elements. In the last few years, I've been putting a lot of research into a system I call CubicWonder. So I'll start by showing you introduction of CubicWonder with the Chico and Chica cubes. Now, as you see in front, the Plato Cube and the Bucky Cube are both contains 8 Chica cubes. Now, each Chico and each Chica cube contains 5 solid pieces. I show more info in the earlier videos on this if you want to watch it. But on this video, I want to focus on the periodic table and the elements. Now in front, I'm showing you the periodics of the Bucky Cube and the Plato Cube. Now they are integrated geometry, but you see the 1, 4, 4, 9, 9, 16, 16 come to 59, and it's the same with the Plato Cube. So when we add the two 59s together, we get 118 elements. Isn't that something? Now the difference between this and the normal periodic is this is 3-dimension and the normal periodic shows flat squares. So you can see in front that the Bucky Cube is surrounded by 8 Plato cubes. Now that's a big difference. Now you can also see that the symmetry is perfect between the Bucky cubes and the Plato cubes. I'm going to take 2 or 3 blocks away and give it a rotation. And then I'm going to focus on some of the 3D geometry of the Plato cube and Bucky cubes. So this will probably need the quad step system of balls as well. Okay, for this I'm going to start by showing you a Bucky cube with 2 quad step rings surrounding the Bucky cube. Okay, I'm showing that we have a 12-ball ring on the top and a 16-ball ring and a 12-ball ring further down. Now you can see that the corner pieces, the green and white corner pieces, don't line up with the center of the balls. So we're going to get rid of them. So now you can see that the Bucky Cube has turned into a cube octahedron and the balls line up to the vertices. Okay, I've called this the B2 molecular geometry. The next one's going to be the B3, and this is going to show the yellow tetrahedrons. And you can see that the vertices of the tetrahedrons align up to the center of the balls of the rings. Okay, the next one I'm going to show you is the B4, and this is going to be the purple tetrahedrons. And you can see on this one, the vertices of the purple tetrahedrons, they all line up in the center of the quad step balls. Okay, if you look at CubicWonder, you have the Plato and the Bucky, and you have a red, cyan, and blue half octahedrons wrapping around the both cubes. So let's start with the red. And you can see on this one that the vertices are going to the center of the rings, no problem. Now notice that the 16-ball ring gets a red one in the center, but I don't see one coming up on the 12-ball ring. Okay, now we have the blue 2 halves. Now notice on the 16-ball ring, the 2 blue halves are using the red balls, but the different colored balls on the top and the bottom. Okay, the next one coming up is going to be the cyan. So that makes the 3 of the half octapieces. Actually, it makes a complete octapiece. And CubicWonder has a 4th octapiece. That's the green and the white one that comes in the center of the Plato Cube. Okay, I've got one more piece of geometry to show you for the Bucky Cube. And this is going to show the linear parts of this geometry. Now this is basically the vector equilibrium, as taught by Buckminster Fuller. But his geometry, they seem to forget all his geometry and then gone back to two-dimensional equations. They tried to push all his geometry off the face of the earth. And the Mathematicians Forum would say only a crank would work with trivial geometry. It beats me how the mathematicians can see all this by just using geometric equations. Anyways, now I'm going to show you the 3D geometry of the Plato cubes. So I'm going to start this by using the letters P1. And I'm going to show you first the full Plato cube. Okay, the next one I'm going to show you is P2. And this is going to be the purple and yellow together because it's the Star of David. So this breaks down into 4 yellow tetra pieces and 4 purple tetra pieces. Okay, the next one is going to be P3. And this is going to be the octahedron. And this splits into 8 pieces. 4 white pieces and 4 green pieces. And remember, it formed the corners of the Bucky Cube. So it duels between the Bucky Cube and the Plato Cube. Okay, we're back to the red, cyan and blue octa pieces. These half octa pieces were in the Plato Cube and the Bucky Cube. They're orientated a little bit different in the Bucky Cube. So this one I'm calling P4. So now we'll bring the next one will be P5. And this one will be the blue. So the next one coming up will be the P6, so that's going to be the cyan one. What's amazing about this is that the colours, there seems to be about 7 colours altogether, and it works out so perfect. Isn't it amazing? So the next one coming up is going to be the P7, and I'm going to make this the linear one. It would have been P8. But I used the dual tetrahedron as one. I think the linear is the best method for looking at the geometry because it's easier to figure out. Okay, in this next animation, I'm going to show you the Plato Cube and the Bucky Cube both rotating around together. And I'm showing you the 12 ball and the 16 ball rings and how they all sit together. Now if you look at the rings themselves, the balls are touching going around, so there's no gaps. So basically it's perfect geometry because the 16 and the 12, the balls are all in a perfect ring and they just touching each other. So what you're looking at is a perfect mathematical fit. So my next anim, I'm going to show you the Plato and the Bucky with the linear geometry. I think this geometry, looking at the two of them, is the best way to figure out the geometry of the molecules. They do not teach the Bucky Cube and Plato Cube in academia. This is my discovery, and it's been given the cold shoulder. I think this linear geometry will make the outline to all the pieces that I showed as solid pieces, because looking at this, it seems to give you the outline geometry of all them pieces. Now I show in this geometry of the elements, you get 8 Plato cubes going together. Now I'm checking the molecular structure of iron, and it shows 8 cubes for the molecular structure of iron oxide. I downloaded a clip, so I'm going to show you the clip. So you can see that the 8 Plato cubes matches the geometry of iron and oxide. They show 8 cubes also. I'm afraid I don't know much about the chemicals and stuff like that. That's not my line of work. But anyway, I think I've showed you enough for today. So this is Paul saying thank you very much for watching the videos of order and not chaos.